Hello guys, I am a bit early to celebrate something. We have completed 71,000 subscribers on Olympiad Corner, and this year we plan to move it to 100k with your support. First of all, just tell me, am I audible? Just tell me if I am audible. I think I am audible, right? So 71,000 subscribers. Many would say, sir, why you are celebrating 71,000? It is not 75, it is not 50. Why you are celebrating 71? You know what is 71, right? 71 is a prime number, its reverse is a prime number, and then 7 is a prime number, 1 is a number which is neither prime nor composite, and 7 square plus 1 is 50, right? So it's a very special number, and that is why we are celebrating it. I have planned to celebrate 73,000 subscribers as well. So it is upon you, it is on you how much faster can you get us to 73k. So please share these videos with majority of your friends, right? Perfect, right? Sum of ranks of two educators of an academy. Yes, this is just a, yeah, that is one coincidence. Yes. Okay, so today is a very special lecture when we dive deep into one of few of the famous theorems, right? So we are going to start with something very amazing, but before that, like, these are learners who excelled with me. All of them cleared IUQM as well, right? IUQM was the starting point for them, and then they made it big, right? So that is what we say: pigeon today, IIT tomorrow. Today is the last day to subscribe, right? Because uh, tomorrow prices are rising. So if you want to enroll in an academy, in JEE subscription or any subscription, then you can take it today. So we have 13 learners in top 100. Amazing things are going on. This is my Nimbus batch, 500 plus live lectures, 20 plus tests, class 11th. So you can enroll today. Like I said, if you want to enroll for the Ramanujan batch, I am teaching live there, in Hindi, Tuesday and Thursdays, right? And we have 4 classes per week. 2 are being taken by Ajay sir, 2 are being taken by me. Okay, perfect. So 805 learners qualified for RMO 2024 last year. So the result was jubilant last year, and this year we are targeting for 1,000, right? So if you want to be among these 1,000 learners, just write, let's crack it. Let's crack it. Let's crack it. Let's write, let's crack it in the chat. Can I have let's crack it in the chat? Perfect. Majority of the learners are saying, sir, that we want it. Okay, perfect. Now, these theorems are also useful for JEE as well, right? JEE, there are certain problems which can be solved using longer methods of JEE, but with these theorems, these methods, those methods, become literally very, very simple. Okay, so let's get on with it. First of all, we will study concept of invertibility, mod prime, mod prime, right? What do I mean by invertibility mod p? It has a very simple thing. So I take a set A which consists of 1, 2, 3 till p minus 1, where p is a prime number. P is a prime number, right? P is a prime number. Then I write 1 into 1 is congruent to p minus 1 into p minus 1 congruent to 1, mod p. And then I write, this is first. Secondly, I write, if A belongs to capital A, right, there exists unique B belongs to capital A set such that AB is congruent to 1, mod P. And A and B are called inverses of each other. Inverses of each other, right? Inverses of each other. For example, and B is written as A to the power minus 1. This is the concept of invertibility, right? This is the important, this is the concept of invertibility. Okay, okay. This is the concept of invertibility. B is equal to A inverse. Now, let me go through. Let me go through an example so that you all can understand. Let's take the prime number 11, right? So can I say that my set A is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now my first part says that this number and this last number can be like they are self-inverse. So 1 is the inverse of 1 and 10 is essentially minus 1, right? 10 is essentially minus 1 mod 11, right? We are talking about mod 11. So this is the first sentence. If you are getting till here, please write DN. Please write DN in the chat. Please write DN if you are getting till here. Hello, hello, hello. Please write DN if you are able to understand till here. Done. Nice. Now, what did I say? See, like every A has a unique inverse. 1 is self-inverse, minus 1 is self-inverse. Let's talk about 2. Let's talk about 2. Can you see that 2 times 6 is congruent to 1? Mod 11. So 2 and 6 are inverse of each other. 2 and 6 are inverse of each other. Similarly, 3 times 4. 3 and 4 are inverse of each other. If I talk about 5, 5 and 9 are inverse of each other, which leaves me with 7 and what else? 8. They are inverse of each other, right? So every number has a unique inverse. 6 has 2 as inverse, 2 has 6 as inverse, 3 has 4 as inverse, 4 has 3 as inverse, 5 has 9 as inverse, 9 has 5 as inverse. Similarly, 7 and 8 are inverses of each other, right? Am I making sense? Am I making sense? Am I making sense? No, not for every number. This is for prime numbers. This is for prime numbers. And why this happens for prime number, we will do it in the next page. So like this is the concept of RMO. This will help you in writing the answers. That is why we prove it, like we prove everything. Although these are name theorems, you can use these theorems directly in RMO, right? You can quote them. This is like by Fermat little theorem. I am writing something, right? Right? So we are doing whole calculation mod 11. So invertibility is a concept which is dependent on which divisor are you taking. So if you are taking 11 as divisor, then 2 and 6 are inverse of each other, right? Otherwise, if you see 2 times 4 is 1 mod 7. So when we are talking about mod 7, 2 inverse is 4, 4 inverse is 2. So inverses are dependent on the choice of divisor. If you are taking mod 11, basically the inverse is different. Getting my point? Getting my point? Getting my point? Right? Now, with example, we can understand that this is unique, but we have to prove it, right? Do you agree that we have to prove it? Right? Uniqueness of B has to be proved. Uniqueness of B has to be proved. Do you agree? Do you agree? Right? So just write DN so that I can move on to the next page. Can you write DN so that I can move on to the next page? Very good, Abhimanyu. Right? Let's go on. Let's move on. Okay, perfect. Now, I am going to prove it by contradiction, right? Let B and C belongs to A such that AB congruent to AC mod P congruent to 1, right? Let's just write this. Okay. Now this means that A times B minus C is congruent to 0 mod P. Right. Now since this is a prime number, and now you will understand why we are doing this thing for prime number. Can I say that A is co-prime with P, and since this is congruent to 0, it implies P divides A times B minus C. Now since A and P are co-prime, this automatically concludes that P divides B minus C. And how can it divide B minus C? How can it divide B minus C? The only possibility is B equals C. So your choice of B and C, can only be equal, which means B and C has to be equal, right? 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 Do you agree? Do you agree? Done? What does mod P represent? Please refer to the earlier lectures. You'll not be able to understand this lecture before going through the first two lectures. This is not a Tom and Jerry show, it is a Sherlock Holmes show. Sherlock Holmes show are connected to each other. These are not something which you can see and laugh it out in every moment. You have to see all the previous lectures to understand this. Right? No, no, no. A is co-prime. See, like all these elements are co-prime with it, right? See, like all these are remainders mod P, right? So all the remainders are co-prime with P. That is the definition of prime number. That is why this is the whole point of taking the prime numbers, right? Right? This is the whole point of taking the prime numbers. So now what we are reasoning here is, if these two are congruent to 1, leave this part. If these are congruent basically, then this is congruent to 0 as per our properties, the properties which we have studied for mod. And this is mod P, by the way, this is mod P. So what is congruent to 0 means? Congruent to 0 means P divides this. Now since A is co-prime with P, P cannot divide A. So P has to divide B minus C. And P divides B minus C. See, what is B minus C? B and C are these numbers, right? Right? So can you take any two numbers, subtract them and get P or 2P or 3P? No, you can get only 0. You can get only 0, right? Right? So that is why we say B equals C. Okay. So this proves the uniqueness. This proves the uniqueness. Okay. Now, if I simply say 1, let's multiply these two numbers. 2, 3, 4, P minus 1. Okay. So these are even numbers. So I have taken P as odd prime. Odd prime. So can I say that these are even number of terms? even number of terms. These are even number of terms. Can I say this thing? These are even number of terms. Can I say these are even number of terms? Right? 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 I am talking about this product. So this product is actually p minus 1 factorial. P minus 1 factorial. This is what? P minus 1 factorial. Right? But if you see, this is 1, this is 2. There will be among these numbers 2 inverse. This is 3. There will be one number which is 3 inverse, and so on. And lastly, p minus 1 is minus 1. All other numbers will have inverse here. Now 2 times 2 inverse is 1. You have 1 everywhere, and in the last you have minus 1. So can you say that p minus 1 factorial is congruent to minus 1 mod p? This is your Wilson theorem. This is called Wilson theorem. This is Wilson theorem. This is Wilson theorem. Please note it down, guys. Please note it down. This is the definition of factorial. This is the definition of factorial. What is n factorial? If you have not studied it, please write it down. N factorial is n times n minus 1, n minus 2 till 1. So it is a continued product till 1. It is a continued product till 1. Got it? So what did I get? P minus 1 factorial is congruent to minus 1. Right? So one important corollary here is if p minus 1 factorial plus 1 is divisible by p, then p is a prime number. Then p is a prime number. Then p is a prime number. It's a very, very important thing. It's a very, very important thing. Like it cannot happen for non-primes. It cannot happen for non-primes. It can happen only for prime numbers. How do you get 2 inverse? See, like earlier I proved that among the set 1, 2, 3 till p minus 1, there are inverses of each other. Right? We proved it. So there will exist some basically some inverse. So just to give you a context, let's write for 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? Right? Now 1 is 1, 2, write 6 here, which is 2 inverse. Then 3, 4, with 5, write 8, no, 9, and then 7 and 8, and then write 10 as minus 1. So can you see, this is 12 which is 1, this is 12 which is 1, this is 45 which is 1, this is 56 which is 1. Right? This is how we get minus 1 in the end. This is how we get minus 1 in the end. Okay? Okay? Are we getting it? Done? Perfect. Perfect. So let's do some problems. Find remainder when 11 factorial is divided by 13. So if you are asked this question, how will you do it? How will you do it? Give me the answer. Give me the answer. 1. Anuj is saying 1. Yash is also saying 1. Okay, let's see. Let's see. First of all, can I say that 12 factorial is congruent to minus 1? Mod 13. Right? Now, I need 11 factorial. So, I will write it as 12 times 11 factorial is congruent to. Now, minus 1 is congruent to minus 1 plus 13, that is 12. That is 12. Right? So, it is 12 mod 13. Since 12 and 13 are co-prime, we can simply cancel that. So, 11 factorial is congruent to 1 mod 13. Okay. 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 Do you get it? Do you get it, guys? Guys. Done? Perfect. No, 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 no. P minus 1 is not present. That it is 11. No. No, 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 no. Don't do this. Don't do this. Don't do this. Don't do this. I won't write it. Like, I do not consider this as a valid like this thing. So what you are trying to say here is, sir, you can simply write P minus 1 factorial is equal to minus 1. Then P minus 1 into P minus 2 factorial is congruent to P minus 1. And then you can cancel here, and P minus 2 factorial is congruent to 1. I would not remember it as it like this. This is a logical explanation, but I won't remember it like this. I won't remember it like this. Okay? It is upon you to decide. Okay? Another problem. Find remainder when 42 factorial is divided by 47. What is the remainder when 42 factorial is divided by 47? Let's see if you are able to do this. Let's see if you are able to do this. Yes. 42 factorial is divided by 47. So if you are watching it in recording, then you can simply pause this video and to solve it. Right? I am going ahead with the solution. Again, can I say 45 factorial is congruent to 1? Right? You told me to use that. Okay. Now simply write 45, 44 and 43. These are the additional numbers. 42 factorial. Right? Now, this is 1. I can add 47 here. So it will be congruent to 48, right? So I can write it as 15. I can write it as 16. Then I can write it as 42. I can write it as 8. Sorry, 22. Sorry, 22. 22. Right? Now you have 15, 22 and 43 is as additional number. Right? Write 42 factorial separately. You have 8 here, add 47 in it. So you will have 55. 2, 5, 3. Right? So you have 6 here now. So 42 factorial times 6 times 43 is congruent to 1, which is again congruent to 48, which again gives you 8. So you have 42 factorial times 43 as congruent to 8. Okay. Are you getting my point? Are you getting my point? Are you getting my point? Mod is mod 47. We are solving mod 47 now. We are solving mod 47. Right? Right? We are solving mod 47. Now we have to find multiple of 43. Right? We have to find multiple of 43. So basically, see this 8. You can add only multiples of 47. So 47q plus 8 is equal to 43q, 43p. So can I say 8 times, just a second. Can I say 47q minus 43p is equal to minus 8? Right? So if you see, yes. So this is the equation now. If you see, this is the equation now which you have to solve. Right? So simply, if you take q equals 2 here and p equals 2 here, sorry, what I'm trying to say, if you simply take p equal to q equals to minus 2, what do you get? Just take minus 2 common, and then you get 47 minus 43 equals minus 8. So this is one solution. This is one solution, right? Minus 2, minus 2. Okay. To get the next solution, you have to add 43 here. So if you add 43 here, you get 41. Okay. And for the next solution here is, you add 43, so you get 45. 40, like you have to add 47 here. This was an indeterminate equation. We solved it in basic of mathematics. We solved it. You simply have to add 47 here. The coefficient of q is to be added here. The coefficient of p is to be added here. 41 and 45. So, but this solves the question for me. This solves the question for me. So since I have 41, so I simply have to write 42 factorial times 43 is congruent to 8 plus 47 into 41. 47 into 41. Right? Right? Now, if you solve it, what is 47 times 41? See, like 47 times 41 is actually equals to 44 square minus 3 square. Right? 44 square is 1936. So this is 1936 minus 9 is 1927. And then you are adding 8 here, which becomes 1935. So this is 1935. And have faith, it is divisible by 43. Because we have calculated it. So this is 4, right? 43 4s are 86, 172. And then 215. So 45. So 42 factorial is congruent to 45 mod 47. Abhimanyu, did you get it? Abhimanyu, did you get the answer? Yeah, see, like, I understand your point, but did you get the answer? 45. I guess Yash Pillai was the first one. Yash Pillai was the first one who got the answer correct. Yash Pillai was the first one who got the answer correct. I believe. Got it? Perfect. You both got it. That is the only important thing, right? Now let's move on. Let's move on to the next thing. Let's move on to the next thing. Now, let me see. Just a second. Yes. Let's take any. Let A belongs to capital A. That again, that set. A was 1 to P minus 1. Consider a set B, which is A, 2A, 3A, 4A, P minus 1A. Right? I have this as my set. Right? How many elements does this set have? Number of elements in this is P minus 1. Right? It consists of P minus 1 elements. Yes, Anurag. It is there. It is there, obviously. Anurag, it is there. How much rank did you get? How much rank did you get in JEE Main? Right? Let's go ahead. Let's go ahead now. Now, what I will say that every element of B is having a unique remainder. Unique remainder. So what I'm trying to say is A is congruent to R1, 2A is congruent to R2, P minus 1A is congruent to this, and all these remainders are unequal. All these remainders are unequal. All these remainders are unique. Okay. All these remainders are unique. All these remainders are unique. Let me prove it again. Again, I will go through. Now, since like A is co-prime, I'm just writing it here. I will go through contradiction. Okay. So Ri is I times A congruent to J times A. I minus J, same logic, times A congruent to 0, which is possible only when I equals J. Right? It is possible only when I equals J, because then P divides this. P can divide I minus j times A only when I minus j is equal to 0. Right? Am I making sense, guys? Am I making sense? Yes, the price amount will remain the same. Right? Am I making sense? Perfecto, perfecto, perfecto. Let's move on. Right? Now let me multiply all of them. Let me multiply all of them. A, 2A, 3A, P minus 1 into A. Now all these remainders are nothing. See, like these remainders are permutation of these remainders, because these are the only remainders which are possible. See, like these are P minus 1 remainders. Mod P, you can have only P minus 1 remainders. Like one remainder is 0 obviously, but we are not taking 0 into our set. So there are only P minus 1 remainders. All of them are unique. It means this complete product has to be equal to this product. And now we can cancel. 1 gets cancelled with 1, 2 gets cancelled with 2, P minus 1 gets cancelled with P minus 1. All of them will get cancelled. How many A do I have? P minus 1. Everything is cancelled here. Mod P. This is your Fermat little theorem. This is your Fermat little theorem. This is your Fermat little theorem. Got it? Got it? Right? Sir, if this is special case of Euler, then why don't we study Euler first? See, like, Abhimanyu, now that you have studied Euler, right, you must have understood that the proof of Euler was much more difficult than Fermat. So, to help everyone understand Euler before going through these two theorems is a tedious task. Like I have done it before. I have taught Euler first, but the learners were very uncomfortable studying Euler first. Right? Perfect. So A is co-prime with mod P. You can find it like this also. And then your need for A to be co-prime with P goes away. Right? If A is not co-prime with P, then also this is valid, this is valid, then also this is valid. Right? Perfect. So see, like in all the remainder problems that we have studied, we need a power which, when you take the power on A, it should become 1. So FLT helps us in finding that power. Right? So for example, this was a problem in JEE Main. This was a problem in JEE Main. Find remainder when 5 to the power 2027 is divided by 11. Divided by 11. Can you find me the remainder? Can you find me the remainder? Find remainder when 5 to the power 2027 is divided by 11. Done. 3 is the answer. Let me check. Let me check. Now, what? How does this help me? 5 to the power 10 is congruent to 1 by FLT. This gives me 5 to the power 2020 is congruent to 1, which is perfect. No problem. But I have 7 powers additional. I have additional 7 powers. So 5 square is congruent to 3. 5 to the power 4 is congruent to 9. 5 to the power 6 is congruent to 27, which is congruent to 5. Mod 11, right? Which is congruent to 5 mod 11. 5 to the power 7 is simply 25, which is again 3. I think, yes. Now, if you multiply these two, you get 5 to the power 2027 is congruent to 3 mod 11, which is your answer. Which is your answer. Okay. Okay. So, the real benefit about this is you got this first, right? You got this first, right? Right? You got this in the first step. Otherwise, without knowing this theorem, majority of the JEE aspirant try to find it like this. Try to find it like this, right? Like this. Okay. I hope I'm making sense, guys. I hope I'm making sense. But what if, sir, what if my remainders, like my divisors are non-prime? What if my divisors are not prime? What happens then? Right? What happens then? Let us see. Let us see. Let us see. How to calculate 5 to the power 7 mod 11 quickly. Like this. I have shown you the steps. Right? I have shown you the steps. Okay. Now let's solve. Right? In the last lecture, we solved simultaneous congruences, right? Let's solve this. Solve the simultaneous congruence. Congruence, right? Not 5. 2 to the power 100 congruent to mod 4 and 2 to the power 100 is congruent to mod 25, right? So the solution will be something mod 100, right? This is what we have studied. We'll always be able to find answer mod 100. That is LCM of 4 and 25. So can you fill in these 3 blanks? Can you fill in these 3 blanks? Fill these 3 blanks for me. Fill these 3 blanks for me. Ranker reward program is based on the ranks. So if you get first rank in JEE Main, you get 11 lakh rupees. It is like that. One. Fill in the blanks. So 0 comes here, right? Obviously 2 to the power 100 is divisible by 4. Okay, so this comes here. Now if I talk about mod 25, I clearly know that 1024, right, it is 2 to the power 10, is congruent to minus 1 mod 25, which gives me 2 to the power 20 congruent to 1 mod 25. It is about knowing the powers of 2. That is why I gave powers of 2, right? That is why I gave powers of 2. 2 to the power 100 means 1 mod 25. So this gives me 25. No, 1, right? This gives me 1. This gives me 1. Okay. So if I write the sequence of numbers which are 1 mod 25, it will be like this: 51 and then 76. So if you see, this is 1 mod 4, 1 mod 4, this is 2 mod 4, this is 3 mod 4, and this is 0 mod 4, which is required. So the answer will be 76. So the last 2 digits will be 76. Last 2 digits of this number is 76. This is going to be a problem in IOQM 2025 for sure. In IOQM 2025, you will be asked last 2 digits of something. It is a certainty. It is almost certainty. Right? 014? How did you get 4? How did you get 4? How did you get 4? Everyone is writing 4. How come everyone is writing 4? Have I made some mistake here? Or I am right and you are wrong? I think you all are wrong. This is a 3 marker. This is a 3 marker. I think you all are wrong, guys. Okay, bye Abhimanyu. Right? Perfect. But, sir, we were lucky here. We could remember 2 to the power 10, then we could raise it to 2 to the power 20, and that is how we got 1. How to deal with divisors which are non-prime? Right? How to deal with divisors which are non-prime? Right? How to deal with divisors which are non-prime? Okay. Should we do something about it? Are you ready to study? Are you ready to study that? Are you ready to study that? Yes, that is how we get Euler-Tauschent. So let's define a function, right? Phi n represent number of positive integers less than n which are co-prime with n. Okay, which are co-prime with n. Okay, so this is called Euler-Tauschent function. So if you see, phi 2 is 1, phi 3 is 2. Basically, see, like less than 2, there is only one natural number which is co-prime with 2. So 1. Less than 3, there are two numbers, both of them are co-prime. If you talk about phi 4, right? So write all the numbers less than it. This is not co-prime, this is co-prime, this is co-prime. So this will be 2. 5, 5 will be 4. Please tell me what will be 5, 6? 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 5, 6 is going to be 2. Because only, see, like 2 is 1 is co-prime, 5 is co-prime, 2 is non-co-prime, 3 is non-co-prime, 4 is non-co-prime. So 5, 6 is 2. Right? 5p is definitely p minus 1. P is prime because all the numbers less than 3, less than p will be co-prime with the prime number. Okay? So this is a very important thing. Right? Right? Okay? 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 So now let me write a formula for phi n. So phi n is, if n is p1 to the power a1, p to the power a2, right? So this becomes n times 1 minus 1 by p1, 1 minus 1 by p2, so on, right? For example, let me calculate 500. 100 is 2 to the power 2 times 5 to the power 2. So I will write 100 first, then all the prime numbers like this, all the prime numbers like this. Okay, so this becomes 100 into half into 4 by 5, this becomes 40. Okay, this becomes 40. What is phi of 42? 42 has 3 prime numbers, 2, 3, 7. So what do I get? 42 into 1 by 2 into 2 by 3 into 6 by 7, I get 12. So 542 is 12. Right? 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 If you are able to understand it, just take 2 minutes of time to absorb everything. Just take 2 minutes of time to absorb everything. Am I making sense, guys? Am I making sense? Sir, your lectures are best only in Hindi. I think by virtue of being I am alone teaching in English, it becomes best in English also, right? I am the only one who is teaching in pure English, right? So, and if I am the only one who is racing, then I am going to win because I am the only racer. Don't you think? Yes, there are certain topics which you should definitely do from JEE. Quadratic should be done from JEE. Sequence and series should be done from JEE. Why cyclicity of two-digit number is 20 if its phi is 40? Anuj, you have to give me the answer of this first. You have to give me the answer of this first. Do you agree that this is correct? This is Fermat. This is Fermat, right? This is Fermat. Do you agree? Do you agree that 5 to the power 10 is congruent to 1? But is 10 the smallest number so that it is congruent to 1? No. 5 to the power 5 is also congruent to 1. You can see. You can see. You can see. So, although 540, although 500 is 40, it does not mean that it is the smallest power which gives 1 as remainder. Getting my point? For that you need Carmichael functions. For that you need Carmichael functions. Carmichael functions gives you the minimum power. Carmichael functions give you the minimum power with which you can raise and get the remainder as well. Right? No, I won't teach Carmichael function. Carmichael function is not that relevant. I have not seen any problem of Carmichael function. Right? Okay, moving on. Moving on. Let's move on. Let's move on, guys. So, prove that phi P1 P2 is equal to P1 minus 1 into P2 minus 1. P1, P2 are distinct primes. These are distinct primes. You do it while I get the water. Let me get the water. You do this. Yes. Just use formula. It's very simple. It's very simple. It's very simple. Sir, phi of P1, P2 is actually equals to, as per the formula, it is P1 times P2 times 1 minus P1. Oh, sorry. 1 minus 1 by P1 into 1 minus 1 by P2. Okay. So, if you simply take the LCM, you get P1 minus 1 into P2 minus 1. Okay. 5 times P1, P2. Right? So trivial. Yes. Yes. Right? In fact, what he is trying to say, if A and B are co-prime, then phi A B equals phi times A into phi times B, right? Can you write this? Can you write this? Can you write this? Right? Let's move on. Right? Now, again, we take a set. Let's take set A, A1, A2, AK, phi n is equal to K. I am taking this as consisting of all numbers co-prime with A, with n. Now I am not taking n as a prime number. N is any. N is any divisor, right? So these are the numbers which I am taking consisting of all numbers co-prime with n. So obviously it will be k. In total, there will be k such numbers because phi n equals to k, right? Right? Now, again, I will take another number. B belongs to A. So B is also a co-prime. And capital B is the set which is equals BA1, BA2, BAK. Similar line of working as we were doing. Now I am going to write that all these are unique. All these are unique. Again, by contradiction, if Bij is congruent to Baj, this gives me B times Ai minus Aj congruent to 0. Since B is co-prime with n, Ai minus Aj congruent to 0 implies Ai equal to Aj. So all these are unique. Now again I am going to, and these unique remainders are these only. So I'll just simply multiply them to get this. And that is how I get Euler theorem, which gives me b to the power n is congruent to 1 mod n phi n. Right? B to the power phi n is congruent to 1 mod n. This is the general theorem, right? Where B and n are co-prime. Can you write this down, please? Sir, can I crack IOQM if I start now? Yes, you can do it. Obviously, you have to put in more efforts. Sir, will JEE help in IOQM? Sir, if one's IOQM syllabus is done in 2-3 months from your book, how should he revise? By giving tests. Give a lot of tests. right? Thank you, Yash. Thank you for the gratitude, Yash. Perfect. Let's move on, guys. Now, this is a very important theorem. This is a very important theorem because it opens door for all the things. Now, remainders are much more easier. And just take, let P be a prime number. Then we know phi P is P minus 1. So, this is the theorem. This is Euler-Totschen function. This is Euler-Totschen function. This is Euler theorem. A is co-prime with P. So, do you get Fermat theorem as a special case of Euler theorem? This is Euler theorem. So, like now this is FLT. FLT is a special case of Euler theorem, right? Early bird. I was early bird. I was never a night out. I was never a night out. I was always a early bird. See, like I cannot control my sleep. I need 7 to 8 hours of sleep. Otherwise, I cannot perform. Otherwise, I cannot perform. Right? Perfect. Now, this becomes much more easier. 2 to the power 100, right? We wanted to do mod 25 here, right? So, see, like what is 525? It is 25 times 1 minus 1 by 5, 1 minus 1 by 5, it gives me 20. So, 2 to the power 20 is congruent to 1 mod 25. That is how we get it. Right? Right? Am I making sense? Am I making sense? Am I making sense? Right? Yes, it is perfectly alright, Chaitanya. If you are not being able to understand the proofs, then it is okay. Only tell IOQM. For RMO, you'll have to do better. For RMO, you'll have to do better. Right? A to the power P minus 1 is congruent to 1 mod P. 2 to the power 20 is congruent to 1 mod 25. Yes, by watching lecture again. I'll be teaching till 5:20. Right? In fact, I think this is the last question. This is the last question which I am going to do. A, oh no, 2 to the power, let me write 2 to the power 20, 2007 is congruent to dash mod 1000. Right? Find, you have to calculate this. Today I finally watched your live lecture after covering the previous ones. Nice. CRT. Yes, you can do it directly. See, like the powers. The powers are very easy here. You can do directly with the Euler-Totschen function. The powers are very simple here. No. You can use Euler. Yes. Phi. 1000 is 400, right? So 2 to the power 400 is congruent to 1. Can you write it like this? Can you write it like this? Can you write it like this? Yes, finally. See, like Yash is actually looking at the lectures very, very properly. He has noted this condition that sir, this number and this number has to be co-prime to apply Euler. So you cannot apply Euler here. This is a wrong statement. This is a wrong statement, right? So to do it, how will you solve it? Let me show you how. So 2 to the power 2007 is equal to 1000 cube. Now this is divisible by 8, this is divisible by 8. So you will assume remainder to be 8R. Okay. Now this is 125. This 8 gets cancelled. This is 2004. So 2 to the power 2004 is equal to 125 Q plus R. So now I will solve this. Mod 125. So what is phi 125? It is equals to 100. So 2 to the power 2000 is congruent to 1 mod 125, which gives me 2 to the power 2004 is congruent to 16 mod 125, and it seems the answer is coming out to be same. So your R is 16, so 8R is automatically 128. I guess your answer is coming out to be eventually the same. The answer is coming out to be eventually the same, but it is wrong explanation. If you do this question like this in RMO, you will get 0 marks. I will teach, Rajiv, I will teach CRT in the next lecture. I will teach CRT in the next lecture. So it is merely a coincidence. Why I have used 8R here? Because this number is divisible by 8, this number is divisible by 8, hence the remainder has to be divisible by 8, right? Right? Right, guys? Right, guys? So this is merely a coincidence that you are getting the answer correct. What a coincidence, but it is, right? It's a funny coincidence, right? It's an amazing coincidence. Right? Got it. Now, should I write a 5 marker for you? Let me write a 5 marker for you. Right? Are you ready for a 5 marker? If you do this, I'll give you I'll give you a special gift. This is a PJ exclusive. What do I call it? PJ exclusive. Right? Let ABC be last 3 digits of 7 to the power 9999. Just a second. Last 3 digits. Should I use last 3 digits? Yes. I have to use last 3 digits. DEF be last 3 digits of 11 to the power 999. GHI are last digits of 13 to the power 9999. Find, this is 5 marker, find last 2 digits, of ABC plus DEF plus GHI. See, like these are 3-digit numbers which are essentially the last 3 digits. A special gift for those who get the answer. ABC plus DEF plus GHI. So yes, your bet is 11. You can attempt only once. You can attempt only once. Let's do it. Let's see. Now, last 3 digit is basically mod 1000. Let's do certain things. And there's a very nice manipulation here. So what is 5000? It is 400, right? You can calculate it. So 7 to the power 10,000 is congruent to 1 and it is congruent to 1001. You see, this is 7 into 11 into 13. So I can cancel 1 power here and you cancel 7 here. So 7 to the power 999 is congruent to 143. By the same logic, 11 to the power 999 is congruent to 7 into 13, that is 91. 13 to the power 9999 is congruent to 77. Right? So just add these 3 numbers. You get 211 and last 2 digits are 11. So yes, you are indeed correct. So yes, you are indeed correct. Okay. Anuj, you got the answer after I wrote the answer, but Yash gave the answer before you. So Yash, you can DM me here for your special gift. So basically, Yash gets free access to Ramanujan course. Free access to Ramanujan course, right? So he gets free access to Ramanujan course. This is the special gift for this question. Sanhit Maiti, sir, you have replayed a really significant role in my INMO selection. But sir, don't you regret the fact that you are AIR 42 and still here teaching 13 students live? You could have got a lot ahead. See, I am already ahead. I am already ahead of many people. I have written 19 books. I have made a video on it. My earnings are way more than any CEO of a very big company, right? Every year I earn a lot, so that is money. I am respected by thousands of learners, so that is respect, that which in turn gives satisfaction, and I am sufficiently famous, right? So I get all the 3 things. No, I am not joking, Yash. I am not joking, Yash. I am not joking. This is because of your diligence. This is because of your sincerity. This is because of your discipline. You have been coming in my lectures for quite some time. And you have, see, I already told you that this is a special question. This is designed by me. And you have answered it. So you get free access to Ramanujan. So just like take the screenshot of this thing and send it to @Prashant42 Jain. The team will contact you and will give you the access. Okay. And this is not only the result of this question. You have been attending my lectures live. I have seen you. No, 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 no. Yeah, mod 100 would have been good. Mod 100 would have been good. Very good, Sayak, to observe this. Okay. So, guys, that is it from my side. I will take over next week. Next week is going to be amazing. Like it is going to be a longer lecture, at least 2 hours of lecture. We will be doing CRT, we will be doing characteristic equation problems. It is going to be fun, right? I hope you are solving my book. All the things are in my books also. You can do the problems from there. Let's crack it.